Anonymous functions are really simple short functions that fit on one line. Here's the general form of an anonymous function. We have a variable name on the left, the assignment operator, the @ symbol or @ operator, in parentheses the input arguments for the function, and then the body of the function, which is just the rest of the line. The input arguments in the function body are similar to other functions that we would save in M files, except that the body is just one expression. What the @ symbol does is it returns the handle of the function, which then gives us a way of referring to the function. This handle is then stored in the variable that's on the left-hand side. So the variable is a function handle variable. So again, the general form is the function handle variable gets the value of, and then the @ symbol actually returns the handle. In parentheses, we have the input arguments and then the function body. Once you've created the function handle variable, the way you call the function is by using the function handle and passing input arguments to it. So it's the function handle variable in parentheses the input arguments. So in a way, the function handle variable functions like the name of the function. So an advantage of anonymous functions is that you don't have to store them in an M file. You can put an anonymous function definition in the command window or in a script or in some other function. However, having said that, it is actually useful to store groups of related anonymous functions in .mate files. For example, if you have a bunch of temperature conversions that you typically do, you could create a bunch of anonymous functions to do these temperature conversions, and then store the function handle variables in a .mate file. And then whenever you want to use those, you would just load the .mate file. So you would have those available to you. Here's an example of an anonymous function that calculates the area of a circle. So cir area is the name of my function handle variable. It stores the function handle, which the @ symbol returns. There's one argument that we pass, which is the radius of the circle. And the body of the function is to calculate the area as pi times the radius squared. So that creates my function handle variable cir area. And so that's how I call the function, by giving the name of the function handle variable and passing a value for the radius. For example, if I say cir area of 4, then that gives me the area of a circle with the radius of 4. Since I did use the array exponentiation operator in the definition, that means I can pass an array. So I can pass 1:4 and get the area of circles with radii 1 through 4. If there aren't any input arguments to the function, you still have to have empty parentheses in the function definition and in the function call. So when I create the function, I have the @ operator to give me the function handle. I have to have the empty parentheses to say that there are no arguments being passed. Here's an example where in the body of the function, all I'm doing is printing a random number with 2 decimal places. So this is an anonymous function that doesn't return anything. It just prints a random number with 2 decimal places. So this is my anonymous function definition. I'm storing the handle of the function in a variable prtrand, so short for print rand. When I call the function, I give the name of the function handle variable, and I have to have empty parentheses, and that's just going to print some random number with 2 decimal places. The reason that I have to have the parentheses here when I call the function is that if I just give the name of the function handle variable, it shows what's stored in the variable. So it shows the definition of the anonymous function. So when I want to call the function, I have to have empty parentheses as a way of saying that that's the function call. So that's one difference between an anonymous function and an M file function.